Hey everybody, and welcome to another Binary Ninja live stream. I'm excited to have you all here. We have a very busy week this week. So let me bring on our first guest. All right, John, I think you're live. There we go. So I teased a little bit in the tweet that we have a like extra full plate of guests joining us. So John's, however, old hat. He's been on the stream several times and he's back to show off something particularly interesting. But I'm gonna make you guys wait for that. John can hang out with me while we quickly do our recap of the week, and we'll talk. Or well, 2 weeks now since we're doing the live streams every other week, and we're gonna show a couple of changes and things that have happened in the last couple of weeks. So let me switch over to Benja. All right. So first, let me. I got too many windows open. We're going to just spin up a latest dev Binary Ninja. And then so one that I get to show off because I wrote it and so it's allowed is the suggestion came into chat to add some better copy paste elements. So thanks to Joe for his suggestion about that. We kind of had some open tickets and I kind of got around to digging into the code and we added several different useful like offsets. So if you're, working with a file and you've got like the raw file offset, you've got the offset from the segment, you've got offset from sections, and the section offsets are based on the name of the section. So you got all these kind of useful ways that you can copy things, and it's pretty simple, but kind of useful, right? So I could just grab one of these, like the file offset in particular, for example, so I can grab that. Then if I go to hex view, I can go to that address to go, wherever I was. I think it was already there. It was already selected, but regardless, if it didn't do that, you could copy addresses, or if you have a separate hex header, for example, you want to add the file in, you can get the addresses from there. So, let me think what else. Oh yeah, is anybody? We got a couple people on the stream, but it's good day to everyone. Say hello. Let us know you're there. I'm hoping we have a lot of questions for the next the later half of the episode. So hopefully folks are ready to engage and chat. But if not, we got a couple of topics. So that's one set of changes that's come in. I was going to go to our closed issues and see what else got closed out this week. There's some tags improvements, some big performance improvements the way that tags work that Glenn landed. So one of the things that we hadn't done is added tags for a couple of like sort of worst case things where it was potentially a large number of tags that could be created. And Glenn has done some nice performance improvements to tags. So if you really want to throw tens of thousands of tags into a database, it's now a lot more performant. So that was another nice big change that just happened, I think, yesterday or the day before. That just got added on. There's a number of bug fixes. There was, I think a couple of the crashes. Oh, Rust CI. So if you've been playing around with the Rust API, we like published it. We put a bunch of warnings on it. So like even if you go to the GitHub and look in the Rust folder, it's like all sorts of warnings. Like it's scary. And this, however, part of the reason why that was is because that we didn't actually have the Rust APIs building as a part of our CI, so it was a little prone to breakage. It was also kind of floating on either just the stable or the latest nightlies. And we've made a change now where it's going to be pinned on a particular release of Rust. And so we'll advertise like this is the version that we've tested this with and it's working with. And you can build with that to get a little bit more reliability if you're working with the Rust API. So that hopefully will improve the consistency of the Rust APIs. Let's see. Anything else that got done last week? I think that's it from. Well, there's another thing that is going to get added. It's not added yet, and that's what we got John on for. So, John, just real quick, why don't you describe this new feature that's about to hit dev, and then we'll pull it up and we'll start playing with it.
So we've had an issue for a while about creating a way to see all the variables in a function and be able to modify types or change names. So it's the new variables view, which is currently a dock widget. Come 3.0 refactor will be a sidebar panel. And from there, you can see all the variables in the function, change their names, types. One of the
I'll go ahead and bring it up and let people look at it. I like to do a little bit of drama, so I don't want to show it right away. But like as you describe it, I'll go ahead and bring it up. We can show it there.
So one of the nice features, which you can kind of already see, is as you step through, it will use user analysis and potentially user input to show you the value of those variables at the point you're at in the function.
And this is the thing that like blew my mind. Like we'd had the variable list for a while on the list of to-dos, and conceptually, like there's nothing fancy about this. We already had like variable lists up. You could turn on to look at the top of the function. You could show variables. So like, okay, great. We have this little sidebar widget. Like, what's different about that? But you even just said too something really interesting is as you step through, right? Which we would normally associate with like a debugger or dynamic analysis. But what we're doing here is we're stepping through statically, and as I kind of go through here, right there, right? So like these actual variables are actually getting updated here at some point. Man, we've got some range analysis that just thinks those could be anything. Oh, there we go. This is another one. So we know those. We know this value is concretely 0 at this point in the program. So it's a little bit like a kind of mixture of dynamic and static analysis.
Sure. So a great demo in that binary is you go to the restricted random number function, which you can see.
Oh, yeah, just
right there. If you hit I, might want to go to disassembly for this one, just to make it easier to see. But if you step through here, you should see.
Oh, do I?
That might be.
Well, hold on. Let me go to low level. I'll actually hit the variable in here. Is that going to do it? Where's my variable?
I might have sent you the wrong binary.
Could be. You can send me a different one if you want. This is.
Yeah, I'll get you the right one from my computer. But long story short, as you step through, it will show you the possible value set of some of these variables.
Yeah. And so just like the short recap is, our possible value set analysis. So we have two kind of data flow systems inside of Binary Ninja. One is just the really straightforward constant propagation. Like we loaded we XORed a register, we loaded some constant, we did some math to it, and that's just like a single value, and that's very fast and easy. We kind of compute that on the fly. Then there's or like all the time. And then there's the possible value set analysis, which can get a little bit more expensive, where it actually takes down like branches, and that's where you get like your SSA form and your fees, and you can merge and do like it's between this value and this value with a step of this, and you get all these like more complicated things. And it's always like that's been in Binary Ninja since medium level IL for many years now. And you could always like you could even hover over variables, and you could see if the possible value set knew anything about it. So that was like always a thing you could do. And so it's just really funny to me that like a variable list is not super impressive or interesting. And oh, there we go. Here.
Yeah, so I just sent you a better binary.
I do actually have one right here, for example, right?
Yeah, I sent you a better version of that in Slack if you want to take a look at that. But in the meantime, I can talk a little more about some of the other features, which, yeah, like you said, I mean, there's a lot of this data has existed forever.
Yeah, it's not new like information. It was always
new information. You could have extracted it if you wanted to, but this is kind of the first time it's easily visible. And if you go to restrict random number now, this one, so if you step, I think it looks better if you look at it in a disassembly.
Yeah, that's fair.
If you start at the top and step through.
It's not annotating now, though.
That's probably a bug where it's not showing the variables.
Yeah.
Oh, because these are optimized, so they're getting compiled to registers instead of stack variables. Go to high, medium, or high level IL.
Yeah, so medium has it here.
Yeah, so you'll see the different code paths where it's either 7 or 12, and then at the very end, it's either 7 or 12. It'll show you that
Yeah.
those
It's
are
one of
the
those two
values.
values.
So yeah, or when you were in disassembly, we've actually decided not to show registers in the variable list. We want to show actual variables. So what was happening is I sent you the release binary instead of the debug binary. So that got optimized down to just everything stays in the register
Right,
instead
because
of having a
it
stack
didn't need to
variable.
spawn the stack. Yeah, it's a
Yeah.
small enough function. Sure.
And you can, so maybe go to one of the larger functions now. And if you go into MLIL and give a variable use some user informed data flow.
Yeah. All right.
So
Let's take.
maybe a good one is the result of the rand function or the time function. You can
Okay.
just tell
Here
it
we go. Yeah, the restricted random number, which right now we know from this that it would be either
7 or 12.
7 or 12, but instead we could actually just make it like 14 or something, right? So set user variable value. This is the
Yep.
user informed data flow system. It'd be like, no, we want this to be a
Constant
constant.
value.
Or we could even actually make it 7 or 12 if we really wanted to. Like we could annotate that here.
Yeah, you can set the ranges. For this example, you might want to set it to 3 or one of the ones that are in that switch case. Just
Okay.
so
Yeah, fair enough.
kind of. But now you'll see that it's highlighted green in the variables list
Yeah.
to indicate that that was a change that you made.
Yep.
And that should stay green as long as that information is the most accurate. So if you get later into the function where the variable gets overwritten by something else, then it will return back to the auto color. But you can see A, the effect of that in the variables list, and B, the effect in the control flow as well,
Yeah.
because it knows. If you right click on those entries too, you get some other options. So you can rename, change type, or clear name and clear type from there, which clear type, that's actually, I think, the only place in the UI where we've started to expose that functionality.
Yeah.
Which is partially because the way that it's being done right now could be done a little bit better as far as the API goes. But that is where you can go if you want to clear your type. For the variables, you have the show first usage option, which will jump you to where they're first used.
Yeah, that's pretty cool.
And if you scroll all the way to the bottom there,
Of this
where you have
list.
some of the data variables,
Yeah.
you can right click and show definition.
Yeah.
And that show first usage action you can also do through a double click. So if you double click any of the variables in the variables list, it should jump you to where they're first used.
And I've noticed too, the other thing is as I select a variable in here, in the main view, it's going to also focus it in the variable list as well too. So if I know any information about this variable from user informed data flow or any other values analysis, like in the program, I can just kind of like quickly eyeball it because it's gonna focus me the appropriate variable.
Correct. If you select a token that's visible, if you select a token that is in the variables list, it will show it to you.
Focus
and right now, that's kind of a unidirectional sync per se. So if you click in the disassembly or the graph, it'll bring you there.
If I click here, single click here, I could double click it and go to the definition. But
yeah, ideally, selecting in the variables list will also highlight the token in disassembly, which should be much easier to do after the UI refactor.
Yeah.
So that should come eventually in a later update.
That's cool. Yeah. So I think this one's a really neat one. It bridges, between static and dynamic analysis in a really, like, literally just like, using your mouse and like, it looks like you're stepping in a debugger when you see these like values appear and disappear, which is pretty cool. So that's a fun feature. Glad that's going to land on dev like any second now. So it's already in a pull request, going through review, and so everybody on dev should be able to play with that relatively soon. And of course, as John mentioned earlier, it's a dock widget, and so right now you can kind of move it around and you can play with its location. We do plan to have this among several of other reviews turn into the kind of CyberArk panel, as we showed off 2 weeks ago, kind of the early look of what that is going to look like.
Well, what other minor detail, which this binary doesn't really, have much use, but there's little letters in front of each of those list items there.
Oh, yeah, that's right. The R's. Yeah, I asked about that.
So that will just tell you what type of variable it is. So those all happen to be register variables.
But down here,
but if you have a good mix of register and stack and data, and you'll have the little prefix to convey where it's sourced from.
Yeah, we need some clever icons for that, but it's a great it's a great view. I like it. So awesome. Well, thanks. Thanks, John, for hopping on. I think we're gonna transition next to something we haven't actually done here. We had to actually fiddle with our OBS layouts to get more people on, but we're gonna bring on several people, and the whole point of this is actually just to chat about like the type system and how Binary Ninja works with type libraries and signature libraries. What's the difference? How do you make them? All that kind of stuff. So let me see if everyone's joining our chat. I told him I'd have to stall for a few seconds because of the lag. So we'll see who isn't joining. But
I'm gonna go ahead and drop off now.
Yep, that sounds good. Take care, John. Thanks. All right, so let's see. Does this work? Yes. Yeah, we got everybody. Awesome. Excellent. So first, let me thank everybody for being here, and let me introduce everybody that's on the stream. In the upper left, we have Dustin, who
Hello.
Folks in the chat might recognize from his handle dphrase in the Binja Slack. He is our sole non-vectorite on the stream today, but he is repping the Binja logo in his shirt there. I noticed when he leaned back. I didn't actually see that earlier, but he's got the Binja shirt on. Andrew, and I think, have any of you been on stream before? This is like the first for all you guys to be on stream, right? Or
I've been on once.
You've been on one other time. Okay, so yeah, I can remember who we've had on, but I always like to get everybody on here. So Andrew, above me, is at Vector35. In fact, he's in the office. It even looks like right now, so you can see he's actually at the official office, and a couple other people working from home. And then to my left, I think.
You're right.
Is my right? Well, yeah. If I point, anyway, it's too confusing because it flips videos in weird ways. No, you're looking at a flip version of the output, I think. Anyway, is Ryan Snyder. So some quick context for everybody on the stream. That there's been several interesting things that happened on the sort of type library front lately. And the first one I want to talk about is what Dustin's been up to, because he kind of was like, "Hey guys, I have something interesting I'm working on. You want to check it out?" And when we saw it, we were like, "Yes, we very very much want to check that out." So do you want to describe a little bit, Dustin, about what you've been up to?
Yeah. So I think it was 2 weeks ago. I watched Jordan Rusty do that reversing that KR challenge where they were arguing about the arguments to get DI bits and a bunch of of the Win32 GUI functions. And I've been playing around for a while with a project Microsoft put out called Win32 Metadata, where they've actually put out type information for all of the API in Win32 and some new WinMD file. And so I decided to just try to translate that into Binary Ninja types, and struggled a bit with the undocumented APIs, but Ryan and Andrew and Peter and the rest of the Vector35 guys helped me sort through it, and now we have the type lib for all the Win32 API stuff.
And I just refreshed the page, so I've got the stream up here. This is the actual repo, so if people watching the stream are going to get the first peek at it. But this is your tool that will generate the type libraries, I take it. And so I haven't tried the type libraries yet. Tell me about what's the expected result, as a user, if they've got this and they use these type libraries, what's gonna, they're just magically gonna get all Win32 type libraries, I guess, right?
That's the hope, barring if there's any issues with, I'm not sure if there's an issue with case sensitivity or something. I thought I had an issue where I had a type defined, but it wasn't being put through to the binary view. But yeah, in theory, if you have this type library, or if Vector35 decides to ship the output of the tool, open up a 64-bit Windows application and just get all of the native types, all of the function signatures for all of the exported types, and all of that just kind of popped into your binary view.
Yeah, and so we had been kind of working, I think, in more of a manual fashion to do this. So Ryan, do you want to kind of describe like the current state of Windows type libraries and what we were doing to create them?
Yeah. So previously, it had been a largely manual process, just prior to the metadata repos being published. But now that those are there, those are absolutely what we should be using going forward.
Yeah.
There's only a couple, like for MSV CRT, we're not going to be able to use this because that's not included last I checked. But this is going to cut down on the amount of manual work pretty drastically.
And it's kind of a trend we've done too, right? Like even a lot of stuff that Andrew's done. Oh, that's right, Andrew. You were on for some of the ARM stuff we were talking about, and that is the where at all possible we'd rather automate stuff. So, Dustin, you mentioned if we choose to ship it, like the answer is yes, we're absolutely going to be shipping some form of this. I think the only thing we're debating internally now is right now it's basically one monolithic library, and we're talking about how we might be able to split them up into separate ones so that you can only load the one for the appropriate DLLs that for the binary that you've got. But go ahead, Brian. Yeah.
We also use type libraries on Windows platforms to carry all of the ordinal information. So with the type library for kernel 32, for example, we ship all of these sets of ordinals from Windows XP on, so that when you load a binary for anything from Windows XP to Windows 10, it will use the appropriate set of ordinals for that platform.
And refresh my memory, but like the ordinals are essentially, instead of calling an import by like the name of the library, it's essentially just like a number that it's going to be using, or is that the function that it's using within the library? Like how do the ordinals work?
Yeah, basically rather than importing by name, it imports by a number, and it's very easy to extract that. It's just that type libraries are made to be flexible, so there's also the ability to store an arbitrary set of metadata in a type library, and as long as the binary view implementation is aware that a type library might be carrying this, you can take advantage of that. So in our PE view, we make sure to look for this ordinal information if it's present.
That makes sense. And so is it the ordinals, are they in the current metadata that you've extracted, Dustin? Do you know, or is that just one thing that like hasn't been pulled out yet?
I hadn't seen them. They may well be there. There's a lot of data to sift through.
Yeah.
One of the things that is in there that's kind of interesting is they've added extra types for like bit field arguments. So virtual protects, old protect, and new protect arguments are no longer just 32-bit integers, but rather they're the Win32 metadata project has defined them as enumerations with all of their values, and I've gone ahead and copied that in the binary ninja type-lib version. So if you go look at an app that imports virtual protect, you'll see the argument type for the new protection type is this new enum, not an integer, which I think is interesting.
Yeah. So we actually already got one comment where Steven says he's excited can't wait for it to try it out.
Repo's public. That's why it took me a secon to start talking at the beginning.
Yeah, that's what I was gonna say. Yeah, so Steven, like you could literally right now do it. So Dustin, like if they want it, it's does the script basically automatically extract? Do you just clone the other repos, or what's the workflow for using it to generate the type library?
Yeah, so clone that last listed repo, Win32JSON. You need to clone that, and then you need to point my script at that / the API subdirectory,
Okay.
and
Yep.
then just give it an output name, and then go drop that into your binary ninja /typelib /x86_64, and yeah.
So let's talk about that real quick, because even when we were talking a little bit earlier, that kind of came up, which is and I'm pulling up like the Binary Ninja user documentation, which is inadequate, I would say, for this question, which is we've got several different places that we kind of can load type information from. And I guess I think it's probably helpful to start, like, I guess just describing, like, what are the different types of libraries that Binary Ninja ships with. I'm going to take a very brief guess at this, and I'll explain my understanding, and then Ryan will correct me, or Andrew, one of the two of them will point out, or Dustin might even too. It's entirely possible, because there's like a lot of different ways that, in fact, when we first shipped Binary Ninja, we had these platform files inside of like the install path, and it would have like linux.c, and it would just have like some function stubs for like libc start. So you could, and that's when you loaded up a binary. Libc start would actually have a pointer to main, and then main would be created as a function pointer, and that's how you would get your main identified. And so I think a lot of people were under the reasonable expectation that, oh, this is what type libraries look like in Binary Ninja. I put some C header in this file, and that's how types are going to get applied, which was unfortunately not really true, and we didn't really have kind of a good explanation for that. And the difference is essentially those platform types were just like a really early sort of precursor, primarily meant for the case of like entry point and marking things as no return. But they were not meant for like a fully featured type system where you could actually add arbitrary types and structures and parameters to functions and have appropriate type information to all of it. Like that wasn't the purpose of that system, but it did kind of look like it, and so it was a little bit confusing, I think, for people. The current like layout, and this is something again next, and I'm going to turn it over to Ryan and let you explain. I guess I can bring up in my VM2 and look at the folders if I've got these installed. So Ryan, the current folders, like if I go to my just install path for Binary Ninja, I've got a signatures folder, a typelib folder, and a types folder. And signatures are what we actually talked about in our blog post. All right, so we actually have a blog post where we talk about using the sigkit generator, and that's for statically compiled binaries. So it's less about applying a bunch of type information and more about like you've got a statically compiled libc or OpenSSL, whatever the library is, and you can actually see the signature libraries that we ship right now by default here. And we are looking to expand those to a broader set of things. And so that's, again, for static library identification. And this, either Andrew or Ryan, like explain to me the difference between typelib and the types folder that exists here in the install path too.
Yeah. So I can take this one. So the types folder is where we keep types that are associated with a specific platform. So if you work with a platform object, you can query types and functions, and those are essentially unconditionally associated with the binary view when you set the platform with the binary view.
So an elf, a Mako,
anything
or
that
PE
is
or whatever,
in those, so anything that is in those C files under types, when that platform is used, will get pulled into the binary view. So this is, and so like the primary use of this was for marking imported functions as no return.
Yep. So that was the one I started with. Like we shifted this at first, and a lot of people were like, oh, this is where I put my type information, and then we're confused when it wasn't quite applying the way that they expected, right?
Yeah, and this is also where like syscall information was read from initially, because when you define a function, you can also give it a syscall attribute, which is how we were able to do pretty rendering of syscalls for, say, Linux binaries.
That's a good point too. Oops, what do I gotta find? Yeah. So
where we started to outgrow it was, like with Linux, where you've got potentially hundreds of syscalls and a lot of types that can be passed to them. If those are just in the platforms file, those are going to be visible in the types view of every single ELF binary that you load into Ninja.
Yeah. So I open a file and I go to like the type viewer, and the good news is we did on the last stable right changes, so we default to user types, not so you don't necessarily get this, but it's still, you don't want to like flood this to be unusable just for the base file, right?
Yeah, and so because the things that are in this types file are always pulled in their entirety when the platform is set, you want to keep this as small as you can. So the sorts of things that you want to be here are like the truly primitive things that are always going to be relevant for a binary of that platform.
And like for example, right now, like these are enums and these are structures for the ELF header itself, which makes complete sense, because if I actually just go look at linear view in my binary, I can actually see how the ELF header is being decomposed into those different types, right? So like I need these type information just to decompose it because it's an ELF, but it's not every type that you might want to have on every Linux system ever necessarily, right? It's just the specific file format kind of headers here. Oh yeah, thanks for the suggestion. Let me pull chat off here. I think I can pull chat. Yeah. Thanks, Valgrind. Sorry, go ahead. Just turning chat off on the display. So yeah, so Ryan, so that's the rationale behind why, like, okay, this platform, this types platform folder is not really meant for all of the type libraries. Signatures, as as we were discussing. Oh, and Andrew's trying to like paste code into the chat. You can talk to Andrew and just interrupt. Like you're allowed to.
Just ignore it.
Well, you clarify later. And then so that leaves the actual types folder. So you were kind of hinting at this, I think, Snyder, when you were talking about how, the type lib the type lib folder, when the types and the signatures, don't really work. So what sorts of things live in the type lib folder now?
Yeah, so we basically use type libraries to allow binary views to implement the role of their platform's dynamic linker. This is because the other shortfall that platform types have is that there's no way to specify where we should be looking for an imported function from. This doesn't matter so much for ELF or Mach-Os, but for Windows, for example, we actually know exactly what module we should be looking for a given import in.
Yeah,
So,
because it's actually specified in the imports. Like that's how you request it in a compiled PE, right? Like as opposed to Linux, where you're like, yeah, please give me this library, and you just get whatever's there.
Exactly. So type libraries allow us to essentially supply a set of functions, but also under the name of a module. So that a binary view, when it knows that it is loading from a set of modules, it's able to look through the appropriate set of them for an import. For ELF and Mach-O, it just has to look through all of them because that's how the dynamic linker works on those platforms. But for Windows, we can scope that search appropriately, which is a good win.
That makes sense. I mean, that's really like we already did half of what a link. There's a linker and a loader, right? Are the two main components that usually like intertwine a lot of operating systems. But we already had the binary view, which is essentially the loader, and it's doing all your mappings into memory. And so the linker portion is resolution of the type libraries now, right? So the idea is that we're trying to produce all these type libraries. And so the actual file format here was BNTL, right? So that's just the binary ninja type library. And we've been shipping these. We've added out a number of them. But there's some more coming. Andrew, why don't you describe what you've been working on the last couple of weeks? I think it makes sense.
Well, I've been working on creating these in Linux automatically, and we have an internal tool, but I've been interested in how to automatically create them. So along with what Dustin's been doing, I'm kind of excited about that. I've been exploring beyond our internal tool. I've looked at, dumping the AST from Clang to see if we can parse header files. I developed a GDB script that can possibly go into a loaded binary with debug information and dump information out of that. But basically, I hope that the next release of BNTLs for Linux binaries will be more populated than the previous release.
I think there's two important things. First is that like Binja itself is just going to ship with a ton more type libraries, right? Because of the automation. Right. So we're going to get, if we get the stuff Dustin's got, even if it gets massaged or split into separate files or however that works, like we want that additional data there, and he's already got a good start of it. And again, the nice thing is y'all can go try it now. So we'd very much like people to start poking at it. So please by all means, folks that do Windows RE, give it a try and see how that type library works for you. But then likewise, the stuff that Andrew's been doing, he's been kind of on the other side of it, where he's got a whole bunch of Linux. Now, what architectures and what when you say Linux, like is it a distro or like what all just?
My main source has been Debian, which currently splits debug information from the ELF files, but it's not hard to rejoin it. And in the case of GDB, it knows which little link to look through the ELF data structure to find it. But basically every architecture but supplied by Debian currently, so it worked for Ubuntu distributions. Their versions like libc.so.6, libpthread.0, but I don't know enough to know if you had some really obscure Linux distribution if they would still work.
But I mean, so the nice thing is, and this is again like to the point about automation, right? Like I think the headline of all this is like there's tools and data that exist that you can automate this stuff, and where at all possible we want to automate it and we want to ship all the stuff that we can do. But even if we don't ship a type library, if it's just a matter of cloning a repository and a tool and running it on your whatever package format to get debug information in, you can kind of create a type library. And actually, on that front, I think, Andrew, you added some new documentation. Excuse me, right?
I not only that, I put some examples in the API. So I think one thing that, well, you've heard me, my kind of push for this is we have to have, if we want to, so we could do, a good job as a developer, but I think really our strength is when the users can use this stuff, not only use it, but generate it. So Dustin's obviously generated something of value here. And if users wanted to make their own type libraries, I think it's important that they have good documentation, that they have examples. So Dustin serves as an example of just, well, how do you actually do it? Give me an example of something that produces a type library with a single variable.
Well, and you heard him say it earlier too, right? Like he had to work with a bunch of undocumented APIs. He asked several different people on our team to be able to get that thing even working. And so it was not as easy as it should have been. So
you don't want an organization with ghost knowledge like that. Like you want it, out there and people can use it. And inside the API now, there's an extremely straightforward. It makes the type library with one example of each type, and it's the dumbest, simplest possible example, which I think is a very good use because it gives you a starting point to build more complicated things like Dustin's.
Yeah. So just to clarify, if you're in the chat, you're looking at it. If you look on so we have our user documentation on just docs.binary.ninja, and this is where the type library information will go. But because this only tracks the stable build, and Andrew committed this code a little bit ago, it won't show up here yet until the next stable build.
Mm-hmm.
But there goes the puppy because somebody's at the door. Hopefully the kids will get it. But if you just go to GitHub directly and go on the dev branch into the type.md file, docs guide, type.md, you can pull that. So this is what you've added there. And then the other thing you're mentioning too is it's not just documentation, but you want to make sure you have an example. Sorry. So Python examples.
They both start with typelib. One's typelib.dump
or
typelib dump.
I'm not actually showing the desktop yet. Nobody called me out on chat.
Huh.
They just seeing our face, right? Typelib dump and typelib create, right?
Right. So if you
let me go back real quick and show them. So here was the actual guide itself, right? So here's the documentation that explains a little bit more about the process for how this stuff works, which is really nice to have it kind of documented there. So that was coming soon for a while, and that's not done. In fact, it works really well because Dustin even asked in chat the other day. He was like, "Hey, it says coming soon. When is it coming?" And I was like, "Oh, it's perfect. Andrew's already working on that." And so you got that.
And then once you look at open up the typelib create example real quick.
Yep.
Oh, you're in it. You can see it's part one name types, and then you see it's example void type class, example bool type class, example integer type class. So extremely straightforward. If you wanted to get started, it's copy paste boilerplate that you can use pretty quickly.
Yeah, that is that whatever format you get your debug information in, you can use this to parse it and create it and save it in.
And there's some exceptional stuff, like when you create a struct, you don't just create a struct, with what you might think would be maybe a list of fields. It instead makes a struct builder of some sort, and then you can call the append method. So it's kind of counterintuitive, in my opinion, but there's an example right in front that you can quickly see and adapt. And then in addition to the documentation there's also the FAQ coming, remember?
That's right. And there we go. So Valgrind is a fan. It says that he might be able to figure it out now. But there is another option too, right? So you can at least create types in with the parse header APIs, right? So Snyder, is it possible to I've got some header file and I want to create a type library from that? Is there a workflow for that as well, or is that something Andrew that you didn't hear?
So there is a workflow for that, and that's actually how we're doing the Windows type libraries that we ship internally. Where the manual portion of the process is getting those essentially headers populated with data that we manually curate, and then the other part of it is baking in a bunch of the other stuff automatically, such as the ordinal information, which is all automated.
And which APIs are? Let me get back to my browser.
Andrew, is there a reason you didn't use the function parameter types when you describe the types of the function parameters? Right, because you can provide a name instead of just saying. Scroll down, Jordan. I was looking at the line. Was it 119?
Sorry, could you repeat the question? The parameters
So
there.
they're not named
So-
parameters.
Yeah,
Oh.
you guys have a type in types called function parameter, which allows you to specify a name
Yeah.
so that they get decorated with the right, name according to the API as well.
Right. Yes, I mean, it's optional, so I just didn't include it. I wanted my supercomputation to be as bare bones as possible, but yeah, it could have a, could have a name in it. I mean, because you could get like a philosophical argument, is the name of a parameter actually part of the type or not? But we certainly, it is useful when we want to track it. So.
Yeah, and in fact, all the libraries we create, that's like half the point is that when you add a useful name to the parameter, it makes life a lot easier.
It does. Yeah.
Yeah, so Peter mentions in chat too. It's a little bit of a spoiler. On like the outline for the stream, I said like, oh, and our one more thing may or may not, like this one more surprise. I think we're gonna have a whole separate section on next week or next episode of the stream, specifically talking to Peter about what he's been doing, because he's got a whole bunch of API improvements on just tons of things. It's also going to touch on the type lib. So we're doing like a big 3.0 refactor of the Python API. So the new API that Peter's implementing, if I understand you right, Peter, is can just take a tuple of a name and type, and then you can pass that in to when you create a type. And so we'll create a name type essentially for you, where the name of the type are associated. All right, so we've got documentation, we've got examples. Let's look at the other one real quick. So that was this one here, Andrew, was your one that actually did the creation, right? Yeah, creates the type lib. And then this is just a little dumper. So you can not only dump one you've made, but you could take the built-in ones to see what kind of data is stored in them and
Right,
dump them out.
And again, if we want to encourage people to use this, not only do we need documentation and examples, but when they do make it, we need a quick turnaround where they can see, well, what did I make? Okay, I produced this thing. What's the output? And then they can loop back around and say, oh, that's not the output I want. I want to tweak it. And right now, the process of moving the output file to the Binary Ninja folder and opening a binary and
Right.
will it load or not? I mean, it's just a lot of friction. I'd rather have it where if we want to go into it or not, maybe a plain text format in the future where you can see exactly what's in a BNTL instead of it being an opaque binary format, which has its benefits too. But I mean, it's just an interesting debate.
Yeah, we talked a lot in our sort of like weekly chats this week in particular about this is a good little prototype to be able to dump the stuff and like, show the output of it. But really, we think like an actual Explorer or UI will be far more helpful. Some easier way for you as a user to debug your own creations and figure out why is my type library not working, or what what data am I not putting in. Oh, we got somebody else who joined or left with it too.
No, I think I shared my screen.
There we go. Yeah, we can switch to that. You can share your screen. Go ahead. You're sharing.
Okay, so this is just like if we had a plain text library, if we had something like an Explorer, anybody that asked the question, hey, what's exactly in a type library, you could see, well, it's really kind of two dictionaries. It's named
No, make
object.
that font bigger, by the way. That's pretty small.
Let's see if we can do it here.
Control-Shift+.
Control Shift Plus. I'm trying, man. Hold on.
Yeah, Valgrind, on the bit length members, that's a different type of refactor, but it is on the list of things we're interested in.
So anyways, if a user was creating these or attempting to create it, they could quickly say, hey, I have these named objects in it, and they could see kind of the hierarchical structure of types. I think that'd be really reinforcing the idea of what they're making. And
yeah, there was a rebellion against XML in our internal call, but everybody concurs that some interface.
You could do JSON too. It doesn't matter.
I feel like a file open that just opens it directly into the types window might be super helpful.
Yeah.
Yeah, I mean, I think especially now the types window has, that's exactly what we were talking about. Is the types window, the typed view now has collapsible filtering, all that kind of stuff. And so if we actually just had the ability to like make a new, it's not like the type view of the binary, but of just that file, to let you explore it. Yeah, I think that would be super useful. So yeah, that's I think what else? We've got yeah, so like lots of stuff where I think by the time that we ship our 3.0, it's looking like we're gonna have a ton of improvements to the type system. So not only do we have all this stuff now much better documented, but we've got like shipping a whole bunch of stuff by default.
You interested in a real quick before and after?
Oh, absolutely. Yeah. If you want to go ahead and share, I'd love to show. Yeah, that was one thing I regret I didn't have.
All right, so I just loaded up iExplore.exe because it loads pretty quick. You can see we've got a handful of definitions that are covered by what you guys ship, but a lot of these don't have types or don't properly have the right number of arguments and whatnot. I don't know what's going to happen if I close it. I'm going to rename a folder that has my type lib in it. Reopen.
You have to share the window again, I think.
Yeah. Window. So one of the problems with the monolib is it does take a second to load. I have some ideas about how to break it up, but I think we need to. I was talking with Ryan about potentially needing an API to talk about dependencies of types,
Yeah.
not functions, but types themselves. Did I not do this
Yeah,
right?
because that's the problem right now. And one of the reasons that the monolib was easier to parse is you could just take all the type data and shove it into one thing, and you knew that all the dependencies are automatically solved, right? Like you don't have to
Right.
worry about that. But if you're going to try to split them up per DLL, now you've actually got to like care about which types from one are used in another. And that
It
tree
looks
can
like
go deep.
It looks like I failed to actually put the file in the right place. So just a second.
No worries. Yeah.
There we go. Much better.
And I'm curious if anybody in the chat has other questions or topic like while we're talking about types.
So now it's got all the.
Oops.
Oh, cool. Ben just crashed.
Oh, good. Yay! Binja crash on stream. We need to get a debug build to figure that out. You are going to be probably loading in. That is the biggest type library we've ever had by a good margin, I think. So
It's down to 6 megs.
It's still I think bigger than any of the other ones that we're currently shipping. But
All right, so I'm not going to resize the window, and hopefully, but yeah, it's got all the definitions. And I think I can go to the type view.
Yeah, I need to pull this up on that sample that we were working on 2 weeks ago.
You can't yet because I've only defined it for the 64-bit platforms.
Oh, okay.
32-bit. I think it's just a matter of.
Well, I was going to ask you about that. You mentioned that the 64-bit was it going the 64-bit type library, but the repo was the 32-bit metadata repo. So is that just?
It's just called Win32.
Okay. Oh, I got you. That Win32. Gotcha.
Yeah, I think it actually is pretty portable. There's an architecture field defined in all the types, and it was empty. So I assume that means it's a generic definition. There's a good possibility I'm wrong about that, though.
So I remember, Ryan, when we were building this manually, we did have to do something different between 32-bit and 64-bit architectures, right? Was there? I'm wondering if that was just more related to ordinals, or do you remember? Am I not? Am I making that up?
Yeah, I mean, they do have to be kept separate just because they're different architectures, as far as Iron Ninja is concerned.
Yeah.
There's nothing really special about how we have to handle them.
I just didn't remember if there were if the actual APIs themselves. I mean, obviously the calling convention changes, but the API.
No, there are actually a fair number of differences.
I mean, yeah, I think there would have to be right because you're gonna have different size pointers. There we go. So you'll have different type information on some of the APIs. Oh, we got a question from Steven. So 3.0 is coming. We do have an estimated release date, but we're never exactly fixed on it. So I actually don't remember off the top of my head. I don't know, maybe Andrew or Ryan might, but I usually just go check the Binary Ninja API repo, and if you go to issues and milestones, 3.0 has wait, you edit milestones. I forget how. Oh, there we go. Yeah, just click the milestone list. So currently scheduled for October 13th. So if your license will last you past that point, then you're good to go. But I mean, the good news is, Stephen, like whatever the way that our stuff works is that if you're on the development build now, like you can get like this variable list that I showed off earlier is only on like a test branch, but that will within the next 2 days be on the development build. And so even though it's not officially 3.0, the UI refactor and these type libraries and all this stuff is going to land before the official 3.0, before it's actually called 3.0, and we release it as such, right? So you should, yeah, if you haven't until November, you should be good. I mean, of course, we're going to have new stuff coming now after 3.0. Just wait for the next release, and maybe we'll be getting those structure improvements that Valgrind was asking about with bit lengths, or something else. So there's always some improvements. Hopefully we can keep you happy. But yeah, the dev branch really has a lot of stuff. Any other questions about types from the chat or anything else that we wanted to cover? I'm trying to remember my notes for my 4 guests. Do you guys remember anything else you want to talk about, or any questions about? Oh, I do know one last thing, but I'll see if anybody else has any other questions first. So the question I have is, Ryan, you have been working on some changes to like the platform system, and I'm trying to remember, and it may just be I'm just wrong in misremembering. Is that related to just microarchitecture, or is it? I think there are some such changes you were working on that were more like about the platform and how we associate type libraries with different platforms, and how some changes might be coming to that. Do you want to like kind of give people a preview of what that is?
Yeah. So this is more about being able to make it easy for users to define custom platforms. So like right now we have a very broad set of platforms. Like we have Linux, we have Mac OS, we have Windows, and those are very broad and they cover everything for those platforms. And because type libraries or like platform types, signature libraries are all specific to architectures or platforms, we want a way for users to be able to like make a plugin that defines a more narrowly scoped platform, and also
And like
to
the
have
closest
the ability,
match would be first, right? Then, so it would be able to like
yeah, like if you
override
want
or
to make
specify
a
additional.
platform for say like Windows 10 drivers,
Yeah.
or if you want to make a Linux platform that is a one specific Linux distribution where you know exactly what glibc is being shipped, like exactly what version of OpenSSL, so that you can include the most specific set of type libraries possible. Or like if you're dealing with a body of software all from one vendor and they use a common set of internal libraries, basically making the ability to register with our existing binary view types a callback that can basically peel those off, so that rather than using our platforms, it will use your platform that you have defined and your set of type libraries that you have approved for use on that platform, so that you, like if you want to say, for example, more thoroughly implement handling of say like Objective-C types in a Mako, this will be your ability to say, hey, this is a Mako and I'm recognizing this as a very particular version of macOS. I implement that platform.
This sounds like
So
something,
that,
Andrew, you were talking about, which is you can't easily load type libraries after you've already loaded a binary. Is that something that you were commenting on too? I think that's a current limitation.
It was a current limitation. Yeah, it goes along with my kind of push for usability and quick turnaround if you're experimenting, creating type libraries. But yes, in my experience, it has to be there at load time when you first load the binary. If you try to use the Python to short circuit that, like to load it on the spot, the functions won't be, like if one of the functions is a named object list, it won't actually be renamed.
So is right? It makes sense then that you would need that as a prerequisite given that limitation. Is there the chance that we would also kind of get both abilities, that you would have, that maybe whether it's an enhancement we can fix or improve to let us do this on the fly and do what you're proposing, or is it an or thing?
they're orthogonal to each other. So the reason that we don't do anything automatically when you add a type library after the fact is that understanding how to apply a type library is dependent on how the dynamic linker on that platform works. And so that is the scope of the binary view. So
That's right. So the binary view itself would have to have an extension that would let it say, "Hey, now I want to add a new thing
everything
after
that we
initialization."
do with a type library
Yeah.
is done by the binary view type implementation.
I really liked your
And
explanation
because
earlier. Where you
there
said it's
isn't
like
a
the
callback-
loader. Yeah, because it's like the loader, it has to be done through the binary view because there's no one right answer on how the stuff gets loaded.
Yes. So what we need to do is for binary view types, or potentially even the platform would be another good place to put it, is add a new callback for when a type library gets added. Because at that point, that callback would be able to know what externs are potentially, what externs could have information provided by the type library that has just been added.
Yeah, because externs are a whole different thing where it's you don't actually have a function to apply the type to, so you have to do it to the extern. You can't do it to the actual function itself because you don't have that library. And so you have to. The fact that you're sort of applying it to this intermediate thing, anyways, requires the knowledge of the binary view for where those got put and how those are mapped in or exposed to the rest of the analysis.
Yeah, and so for the other part of like the platform identification work that I hope to have pushed by Monday is it also solves a problem that we have with, say, RISC-V, where the architecture ID field, like for else, is overloaded between 32 and 64-bit. And we actually need a way to
Oh, do they use like the submachine field instead or something else?
Yeah, and then there's actually another field in the header that's used to cover like the exact architectural extensions that are available. Which
makes sense. 'Cause
right now
RISC-V is
we
so
need to implement as
customizable.
having separate architectures,
Yeah.
and so this callback gives us a way to deal with that as well.
Okay, so that was what I was thinking about was sort of microarchitecture, right? Where you can specifically like do like a flavor of a CPU.
Yeah, because this is a callback that gets back, hey, here's the binary view that we're building. Tell me what platform object to use, or just return nothing, and like we'll go to the next registered callback in the list to see if they have an idea.
So Joe had a question earlier that he asked if types will be able to resolve flags combined together, like mmap. Is that just something that need to be added to platform level? Is this like you've got like masked values like on an enum? Is that the
I think that's one of the advantages to the WinMD approach, where it's changed the type from an integer to instead an enum containing all the values. Is theoretically it's easier to peel apart the bit field, though I can't speak to how easy it is to implement on the binary ninja side.
Yeah, and I don't know what would happen. Yeah, like permission bits, like breaking those out as like, oring a bunch of values as opposed to just like I don't think we have good faculties for that. So Snyder might correct me, but
yeah, that's the sort of thing where like we can probably automate most of type library generation, but then we would want to have some kind of manual set of overlays so that we could apply quality of life improvements to type information.
Yeah.
Just because like for enums, like that's just a huge win.
And it's kind of like an HLIL thing too, right? Where you're actually taking the constant value and saying, actually, I want to be able to display this as the ORs of these separate, bit fields. Like that's like just a whole separate.
Yeah, and we actually have all the code that does that already for data variables. And I think it's just a matter of applying that data rendering code to constants that are appropriately typed in MLAO or high level AO.
Okay, well, good.
So I ran into, I was playing around with my type library and I found a pster instance that points to a constant string in row data. But Binary Ninja can't display it as a string even when I go help because it's not one of the string types. Do you guys have a plan for that?
You could work around it with a data renderer, right? So you can actually have a custom data renderer that would resolve it and render it, but that's maybe not the greatest. I also don't know how. I don't think that works with high-level IL necessarily. So you can't say, like it works in linear view. Like if you had some structure or reference or whatever, you want to be able to render it, like to look up the string itself and render it there. But so I don't think that really answers the question because, like I said, it wouldn't work in high-level IL. So I don't know unless the other guys have a better answer. That's all I got. Andrew was writing. Who's in his notebook?
Let's talk on Slack about it.
Yeah.
I want to know.
Yeah, I have a use case for you.
All
Or I
right.
have a test case for it.
Good. Yeah. Well, that's one we'll anything that we can install like that goes in our weekly chat list, and so we'll discuss it Wednesday with everybody. But thank you everybody for your time for hanging out and joining me on stream. I wasn't sure if we were going to run too long or not, but I don't want to extend it. If there's any last topics that y'all want to hit up before we go, happy to do that, or things that we want to cover. But yeah, I think this will be really helpful for people that kind of want like an overview of like what are all the different types, where do these things live, where's all the and so pointing out those examples, the new documentation, the user docs. I think that'll be good, as well as all the stuff that's coming, right? So there's a lot of this stuff that's coming pretty soon. So Valgrand's question is, why does Binary Ninja represent ranges in the strange half-open range? If I select byte, so like just in the UI, like in the hex editor, is it in like the bottom address selection thing? So if you select a single byte, it's like 14 to 15, as opposed to just saying 14. Oh yeah, Daniel, no worries. So the one more thing was gonna maybe be Peter coming on to talk about all the Python refactor stuff, but we decided that might take too long and there's too many things to talk about. So I think we're gonna put that on for next week. Oh, I'm sure it's his family. Yeah. So they're like, all right, where are you, Dad? It's Friday evening. Come home. So tell him you're coming home now. You can head out, Andrew. But
all right.
Thanks for hopping on.
See you guys.
So yeah, just to get your last question. Ooh, look at that! I got the transition pretty close. Your last question, Valgrind. On the selection, I don't really know why it's like start and like the byte after the end of the range. I don't know. Just sort of tradition. Start and end address. I think it's because if you were to use like our read APIs, you would start at the start and you would take a length of end minus start. And so you don't have to do a subtraction of 1, but I don't actually know. That's a good question. So cool. All right. Well, thanks everybody for hanging out. Thank you for all my extra guests today for chilling. I'm legitimately looking forward to, like I said, hopefully in the next couple weeks we've got a whole bunch of new type libraries being added. Yeah, one more thing is the Python API. Yeah, exactly, which we decided to instead do next week. But definitely go check out the new type libraries in the land. Look for, hopefully next week you'll get a chance to play with the variable view. I think that's really fun, kind of like that static versus dynamic hybrid. And are we working at any new CTFs? We don't have anything major going on. We are working on some CTF challenges, but we don't have anything crazy like some of the Pwn adventures. So we will at some point, but not nothing on deck real soon. So you should see some challenges coming out from us for Seesaw coming up. But yeah, Joe, so that's a good question about that. Actually, I'm going to switch back to just this. I'm going to let Dustin and Ryan go so they don't have to kind of keep hanging out on stream while I answer general questions. So thanks again, guys, for joining me. But the Rust stability. So I think there's a couple of related issues on the Rust stability. I don't know, Joe, by the way, if you caught the beginning of the stream, I talked about some of the summary of the Rust changes at the very, very beginning. But we do now have Rust as a part of our CI because it was breaking too often and too easily. And so we made sure that now like our builds fail if the Rust API is not successfully building. So that I think will help with stability in that sense. Stability in the sense of a complete set of APIs for all of the things, much like the Python API is a fairly complete set of APIs. I don't think we have a timeline for that. What I expect to kind of have happen there is as we run across rough patches in the Rust API, we'll be building it out ourselves. So on that front, I think as early as next week, we should see the debug info API land, and that is the API we've talked about before. It essentially lets you apply debug information earlier in analysis, and the first plugin that demonstrate that is going to be a Rust plugin that we're shipping, a first party plugin. So like all of the usage of that API and any of the other APIs that we had to use in the binary view to get that information out. You know, those kind of worked all relatively well in Rust because we needed them for what we got. So I think we felt like with Python that we really wanted to have like as good of a API as we could because we knew the vast majority of our plugins were going to be written in it. But I think we feel a little bit less urgency in the Rust API. But maybe we should feel it more because I do know there's a couple people excited about it and want to use it. But yeah, long answer to a short question. And then yeah, I mean Ryan obviously has a lot of specific goals with that too, since he was the original author of the API and knows the most about where the bodies are buried. So cool. All right. Well, again, thanks everybody. Good hanging out. Look forward to seeing you in a couple weeks, and we should have lots more stuff to check out. Again, keep an eye on the dev stuff, and we'll catch you then. Take care.